Well, hi, and thanks for joining me here again today in my shop for another session with this radio. I think the focus, at least here as I'm starting this, the focus I'm hoping is going to be on the 31 meter band, which proved to be quite weak relative to the other bands in this radio after completing the alignment process. I still think I've gone through the alignment in a somewhat messy way, but it sure seems like the 31 meter band is weak, much weaker than it should be. It's definitely receiving, but weak. So what I'm going to do is I'm going to repeat the alignment process, but not on camera, at least up until the 31 meter band. That's only step number 5 anyway. And then from there, if I may turn the camera on, we'll do the 31 meter band again. I'm not sure how it's going to get peaked up, but I want to go through this properly. And I'm going to do it off camera up to that point anyway, so my mind is a little less distracted, and I don't make. I'm less likely to make a mistake doing it. And we'll see if we can't correct this 31 meter band today. That's my hope. By the way, here's an interesting observation. These are my two signal generators. So this one's a Second World War type machine. You know, this was probably made, I don't know when, in the 40s maybe? Maybe it's later, maybe it's in the 50s. It's a military grade machine. I turn this on, and within 15 seconds it's producing a signal. The signal comes up here. I turned this on, it came up and said 9512. And it's just sitting there rock solid. And I've noticed this. This guy is rock solid. Over here we have my more modern signal generator. It's transistorized. This one comes up. I have to let it warm up for 15 or 20 minutes before it settles down. It drifts. Get that. The tube one, full of tubes that heats up, is stable from the start. The more modern transistorized one that doesn't need to heat up, needs to heat up before it becomes stable. I think that's a funny observation, so I thought I'd share it with you. So I'll get busy on doing the alignment here, and we'll see what happens. You know, I haven't done anything, just another thought came to mind, and one of the big problems with this radio is the output transformer is shot. But here I am listening to it in my shop. I've solved the problem with, okay, it's a little ugly, it's an external amplifier and a separate speaker, but in fact I can make this radio usable. I'm doing it on my bench, for crying out loud. So that's another possible way for me to get out of the problem of not having an output transformer. Whether I could still use the big speaker, I think I could. I think I could fetch the signal just like I'm doing here, and then drive the signal from here to the voice coil of the original speaker, and just bypass the output transformer entirely. That would also remove 2 tubes out of the radio. And then actually the incorrect tubes I'm using now. So there's a number of pluses to getting around the problem by not looking for another output transformer, but in fact putting in an amplifier, a separate little amplifier. I bet you I have something else around here that I could use instead of that. And surely to goodness you can buy little amplifiers for nothing on eBay and things of that sort. So there's the whole idea. I hadn't really thought too hard about. By the way, I did put a video up, and I asked everybody to make comments on it about the output transformer, and I had not read those comments yet. So when that stage of this whole repair process comes around, then I'll check all those comments. So okay, enough. Get back to work here. Yeah, I think I said something, if I encounter something interesting, I'll turn the camera on. I've gotten nowhere, and already something interesting has come up. Let's take a look at what I'm doing here. Oh, maybe I should rearrange cameras a little bit to make this work better here. Hang on. Okay, so that's 6:40 a.m. and it's being received quite well for radio in my shop. And the first step I was going to take here was just to ensure the RF trimmer and the antenna trimmer for the broadcast band were adjusted properly. And that's why I've turned the cameras on, because things got interesting right away. Now, what did I do with my My alignment tool. Oh no. There it is. Here it is. So this is an oscillator adjustment, and it's step 6 or something like that, 6 or 7. And you do this with the C band. That's that broadband that covers umpteen megahertz. But this has to be the tuning capacitor for every band. These aren't. These ones aren't, for sure. These are only referred to during the broadcast band alignment. These are for other circuits in the radio. This is the real tuning one here. This is affecting the frequency of the local oscillator. That's what I really want to say. Odd to me that late in the game, after setting up the oscillator for the broadcast band, that you would come back and adjust this. But that's not what I'm here to look at. You can see it's open wide, right? Can you see that? You can see the flexibility. It's this one I'm interested in. Look at this one. Okay, it's also open pretty wide. The one in the middle is kind of in the middle. The thing that caught my attention while I was looking at this is this plate here. This plate is bent out. Now, bent out plates on capacitors happen for 2 reasons. One is a really good reason. They're done on purpose by a technician during the construction of the radio, the last stages during the alignment. Exactly why they do this, I think I've had a bit of a misnotion in my head until just this moment. But one of the interesting things about these capacitors, let me rotate it here, we'll take a look at it. So normally, see that outside plate there is bent out, and there's a split in the plate here. And the next plate is not bent out. And this is not the oscillator we're looking at. And you know, am I crazy? I think this plate is bent out here a little bit. You can kind of see it up in here. So the idea here is that these plates, the bent out ones, aren't important until they start meshing. Up until they're meshing, they're just, you know, you can do whatever you want with them, I believe. It's when it's their turn to mesh. So you can adjust the capacitance of the capacitor in various stages across the dial. And I think typically what would happen is you would find this thing is not linear at the low end or the high end, and then you would bend the plate accordingly. You obviously can't increase, you cannot increase the capacitance in any way from its normal. You can only reduce it. You can reduce it. I can't, this trimmer is going open all the way. I can't reduce the overall capacitance of these two guys with this trimmer. It doesn't go far enough. So, am I seeing that somebody else saw the same thing in the factory and decided to bend this plate out? And that's why I turned the camera on, because I want to explore this. I have stayed away from plate bending. You know, I've read about it and stuff like that. I've stayed away from it because I just don't like it. I don't like the idea of it. It's something maybe you would want to do in a more factory type environment than start fiddling around in your home like this. But you know, in today's world, this is the factory environment here. It just doesn't get any better. So you can see it would just start meshing now, and its influence would be significant. I'm just going to move it down. Now look here, yeah, it's definitely partially meshed. And I'm going to let me tune in. There's 640. So that plate is barely meshing, barely reaching it. Let me tune the radio a little bit more. I'm tuning the radio back and forth, trying to identify the sweet spot. On the front it says exactly 640, which is exactly what this station is. This particular trimmer is either the RF trimmer or the antenna trimmer, not sure which one. The RF trimmer is a tuned circuit that comes past the first tube in the radio. First tube is out of sight here. So I'm going to close this, and we're not looking at any instruments here to make any readings right now. We're just listening. Let me just crank it closed. Oops. quieter. Now, so it kind of strikes me that this is getting louder, or got louder. Yeah, there's no sense of a peak. That's what I want to say. I probably need instruments to really see it. So is that the name of the game then? The name of the game is if the trimmer can't do it, you bend these plates out to reduce the capacitance of this part, so this guy comes within range. I know there's also issues on the dial front and linearity and other things. Maybe if you're doing the oscillator, fooling with the oscillator. But so what should I do here? So the only plate that appears to be bent really is this one. Let me bend it and we'll see what happens. So I'm just going to tighten this one a little bit, just so it's not ridiculously open. Okay, these are large range trimmers too. These have a 30 picofarad range in them. Okay, now I'm just going to flex this without bending it. Oh, okay, so if I do it the other way, it's quite noticeable. Oh, I must be shorting it there somehow. So is this just what I should be looking for when I want to accommodate the problem of a trimmer that comes wide open, like the one over here? Now if you remember, do I remember? So this is the adjustment on the C band, and look, it's wide open. So is that a hint that there's too much capacitance in here, and this needs to be reduced? We'll bring this in line into its operating range, and reducing this will then affect the broadcast band and everything all over again. Everything will be affected by this. Oh, I never noticed that gear-driven tuning there. So, what to do? Now you get a good look at the plate down the side here. The meshing of the plates. So now I've got the broadcast band aligned okay on, local oscillator-wise as far as I can see. What I would do then, I guess, with the radio tuned as it is right now in the broadcast band, would close this guy down into a more comfortable location, a more nominal location, and then bend plates to bring 640 back to where it is right now. I can always undo, the plate bending thing is a little hard to undo. You can bend them out easy, you can't bend them back that easy. So it's a one-way trip, and that's why. For this I can do again and again. So let's turn this in. Or am I just messing everything up totally? Here we go. So you see I've changed the local oscillator frequency. The radio's tuned differently now. You can see this is just out here as far as it can go, basically. Many turns past its effective. It's out of range, let me put it that way. So we lock this down. Okay, that's to find the bottom. Back it up. So it's roughly in the middle of its range. And then attempt to bend these plates to bring 640 in on this radio right now. I can flex them without permanently straining them. Let me try. Have to be. Well, let's try with this top. This plate I think is hardly meshing. Let's see what happens here. Oh! Wow. Okay, I like that. That's it. It's fixed. Wow, touchy stuff. Bend this out. I don't want to bend the plate next to it. How do you like that? Okay, untune the radio, double check. Okay, so this is now on 640. This is in a controllable range. So are the other local oscillators for the broadcast band. When I go to the other end of the band, the plate I just bent is out. It's out here. So it can't have any effect. So the rest of the alignment should be good. I think I just made a good improvement. Okay. Okay, so we can assume now that the broadcast band is excellent. That's a bit of an assumption, but we'll assume that. And we'll go up to do the next step. I'm just going to look at the instructions myself here. Just give me one moment here. Be absolutely sure. We just finished 4 and... Oh, wait a minute. I didn't finish 4. I didn't finish 4. There's this guy. So that quieted it. Well, I couldn't really call that a peak, but this trimmer is not way out of whack. It's not open all the way. It's in its range. So the other thing is these trimmers are supposed to be done at 1500, and I'm doing it at the wrong end. And I'm doing that on purpose because the wrong end is what I listen to, the low end. So I really want the radio to operate well at the low end. Because I listen to AM radio all day. No, I don't. Okay. Good. So the next thing then would be just carry on with the next step. The next step is step number 5, 31 meter band, 9 megahertz band. This is the band we're having trouble on. Okay. Just give me 1 second here. Okay, give me 3 seconds here. Very good. So we want to go to the 31 meter band. That. Am I right? Let me get the instructions up here again. I'm just so prone to making mistakes while I'm doing this. I'll blame it on making videos at the same time. Okay, so 9500 is what we want this guy to, we want to check this guy at. Just swing this up here. Did this drift now after that big talk about it never drifts? Did it drift? 9500. Look at that magic eye. Looks good in the camera. I haven't noticed yet if it actually operates. So 95 is here. And do I have the... Wait a minute, I think I'm on the antenna here. Let's get off the outdoor antenna. We'll bring over the signal generator again. Just clipping it to insulation so there's a capacitive interface between the signal generator and the radio here. Okay, we should get this very low signal. Okay, so we have a moderately high signal, but not crazy. 9.5. Hello. Okay, we'll fire out this crazy high, but I mean, the signal generator is isolated by that way I've clipped it on, so crazy high may not be crazy high. Get any clip leads here. Make a mistake. Just double checking. Yes. Should get it. There it is. Now the instructions say to adjust the trimmer on the big tuning capacitor for this band to make 95 beyond 95. Pretty close. I'm going to do that. This time the capacitor is in its range, so I can go this way or that, and I want to go this way. This way? Uh-oh, not quite. Okay, so I got the capacitor open. Oh, wait a minute. Okay, it's open wide again. Got it open. It's totally wide. The screw head's not even touching the moving part, and we're still not quite at 95. 95 is there. Bend the plates more. So now if I bend the plate more, and you know, it would be a different plate at this point, because it's a different plate. It's a different section. It's a different section of the capacitor. That's now, because the section I bent is way out. It's way out of the mesh. So I need to bend more plates. Bend more plates. So it's going to affect the linearity on the dial, but if I, all things going well, it should be a positive thing to do. So, okay, so wait, switch cameras here. I gotta talk to the film crew about this stuff. Okay, there we go. Now, the plate I would want to bend, think about it, and we're talking about this capacitor now. We want to bend one of the plates that is meshed. And these plates have an unusual shape too. Take a look at this. Now, this is no small thing that's going on here. This is one of the most highly engineered parts of the radio, I think. It's expensive to build these capacitors, and there we are. And you could see guys who like to fiddle in their design labs just going wild on how to cut these plates. What's the best way? Straight down or a bit of an angle this way. How many? 4 separate cuts, 3 separate cuts, or 3 separate plates. I could just see the designers of these things just going wild. Now, every one of these 3 looks exactly the same, which would be a manufacturing thing. And now I'm going to bend the plate. I have to get at one of the plates, so I can see now, right down in here. Can you see that? That's better. So now you can see the stator plates in the back here. This plate is bent out a little bit. And that could have been me fooling around. So this plate, the first one with the cut here, now it may sound like, oh, I'm moving that and it's out here in space and yet it's affecting the radio, but these plates, it's all one plate. So if I push it here, I'm pushing the whole thing. Gives you some idea of the sensitivity. So I think the trick in this, let me think about this a little more. I don't think it makes sense to bend this one. Wow, this is because it's going to affect every band when I do this. The problem is there's too much capacitance. Why don't I bend all the sections a little bit? Okay, first one. And just doing this in the blind, like in a manufacturing setting, the guy would have experience. He'd know. From doing this all day long, one radio after another. In fact, this is all he knew how to do. He didn't know how to do anything else. Saw a film once of cars coming off the end of an assembly line. Guys jump in the car, start the engine, and then they have to drive it a short distance through this building. And while they're doing that, what they do is, I couldn't believe it. It comes off the assembly line, they start the engine, they get on the little roadway they're going to drive. They raise the speed of the car up very rapidly and then jam it into park and let it slow down. You can hear the pin clicking in the transmission, and then thunk, and the transmission will lock and the car will lurch to a stop. Like, oh my God, that's one of the final tests is, will the pin stand up? Will the pin even work? Does park work? Basically, is what they're testing. I couldn't believe how they did it. Okay, so I bent these out a micro amount. Now, how do I know I've done anything good here? First, I'm going to tune the radio back to 9.5. Okay, so it's still a little off, but not as much. So I'm going to close this into its range. You know what? I could think of it this way: that this screw, this trimmer, is really the poor man's, maybe not the poor man's, yeah, the poor technician's way to adjust the capacitor. The smart technician's way is to fool with these plates. I wonder what category I'm in. So bring this into its range. It's definitely like this. Now the objective is to bring back the tone, but I'm going to bend the plate. Well, I'm just going to bend them all. Bend them all. That's the idea. That's it. Is that me, or is it's when I tune across it one way, it's of a certain strength, and when I tune across it the other way, it sounds louder. So when I go this way, I get a quiet, and when I go this way, I get a louder. Yeah, it's quite distinct. Must have something to do with the ABC voltage riding on one side, riding a little higher on one side of the tuning point for some reason. I got enough nonsense in my head right now to think hard about that. Okay, we bring it. What are we doing? So look where we are. We're very close to 9.5 now. We leave this in its center thing. See, this is why I shouldn't be doing a video right now, because I should be just. I guess I could bend these plates too. These ones. Never done this before. If I have, I've only poked at it once or twice. So see where we are now on the dial. Didn't make much difference. Let me bend this out by hand here. Well, that's the kind of distance it's got to go, way out there. This one, but that's not the right plate. This is the right plate here. This is the one that's going to have more effect. And you know what? Any lower plate like this one would also be meshed and be having an effect. Okay, tuning. Really close now. So I'm going to bend some of the other sides here because I'm bending these enough, I think. Thanks. I've always been amazed at these, that they can even be engineered and designed and built so the plates the plates mesh so closely. I've always been impressed with those. They must be a very expensive component in the radio. A little more to go, just a little more to go. And the last bit I will use the trimmer. So this is probably a procedure that I need to apply regularly, because there's been a number of radios that I have not I found the trimmer to not be within range. Why exactly that's happening, I don't know. Want to take a crazy guess? Dust on the plates? Changing the effective distance of the plates? That doesn't make any sense to me, but look at the shape on this too. It's not even a smooth curve. It's got a flat area. So, you know, this is all done in conjunction with the front dial and the linearity of everything in the radio. In fact, how much you want to bet the design of these is the compensation for almost everything else that didn't work out in the design of the rest of the radio in terms of tuning linearity. Okay, where are we now? Really close, but a little further to go. Okay, I'll bend a little more because it looks like I've hardly bent this at all. Okay, we're bending them all on the assumption that there's a general. It's not a dial linearity thing we're after. It's a general problem. Ooh, I bent that a lot. Now let's try that. It's a general problem. Well, that's really, really close. I'll show you what it looks like on the dial here. So, you know, I in case you don't know me yet, I really enjoy figuring things out for myself, even if it's painfully slow. That's kind of what I like doing. Fantastic, eh? Now we'll find out what we did to the broadcast band by doing this. We're no antenna, but we might pick up a signal here. No. So I've got a signal generator at 600. I've got a signal generator with no significant output. So this is an unmodulated one, and can't be sure what is going on there. I just jacked the camera up a bit. You'll be able to see the meter in the background there. It's not showing up. So I'll put the outdoor antenna on and we'll listen to an actual station, which is really a kind of a better approach anyway. Oh, it just needs me. Okay, look at this. I'm going to hook myself up to the antenna. And I'm going to take my other hand, I'm going to move it around and see if I can actually conduct the signal with my hand. Where? To here. Get out of here. Really? Okay, I'm going to release with my other hand. Ha! Huh. Isn't that something? I'm part of the antenna lead-in. Small things fascinate me, okay? And that's a good way to be. It really is. Because there's a lot of small things that are actually really big things that we seem to pay no attention to. We live our mundane lives. Okay, radio, how aligned are you still? We're looking to make sure this is rated 640 here. So that's 640. It's just off a bit. So I can easily correct this. The low end we use the inductor. Okay, and we'll just got that noise right beside it, makes it tricky. That's good though, I like that. Now, it's the upper end that may have gotten really beat up in this process. So we'll go up there. 1500. Okay, we'll dial in 1500 here. 1500. Now, didn't we have trouble with this end of the band before? So we're 1465 or so instead of 1500. Get rid of the parallax. A little more volume. Oh wow. Oh yeah, it's 1466, that's why. Okay, so we want this to actually be 1500. The high-end adjustment for this is this capacitor here. Don't get it wrong, Jim. And this capacitor is quite open. It's another case of reducing the capacitance related to the tuning capacitor. Which way are we supposed to go? So I'm going to turn the frequency in the direction we want to go a little bit. And then I'm going to figure out which way to turn this. Unfortunately, it's looking to open even more. Okay, so I've got that capacitor cranked open. The screw will fall out if I go any bigger. Let's see where 1500 really has shown up. Oh boy, oh boy. 1500 is in fact up here. Let's go back down to 600. I want to beat myself to death on this. See, it's a touch off here now. Now it's a question of, is the inductor so far off that it's affecting this high end outside of the range of the trimmer? So I'd either tune this, put the radio back to 1500, and then try to bring in, set the capacitor in its normal position, and try to use the lower end adjustment to bring the 1500 in. I tried this again and again before. It never worked. Let's try it again. Because what I'm thinking is, you know, these things are compensating for each other. So, you know, one up, get out to here, and you got to work your way back in to get it to get it. You may get that? I don't know. As long as I think I know what I'm doing, that's good. That's good enough for me. Actually, you know, there's always an element of doubt in my head about what I'm doing. I don't have that much faith in myself here. It's foolish. What am I doing again? See what happens? I'm making a video, I'm talking to you, I'm losing track of what I'm doing. So we want to try to adjust this using the inductor. So we'll see how sensitive it is. It may not be sensitive at all. I'll turn the frequency generator up just a wee bit, frequency wise. So we can still hear the test signal. Can we move it? With a little bit of movement of this. My gosh, it does move, doesn't it? Oh, I hardly moved it. Okay, we can go back and forth here. The capacitor is wide open, so I'm going to put it in a good range. This inductor seems to move it more than the capacitor. So this is actually the backwards way of doing these kinds of things. That's on 1500, but we're at 1470. So we're going to push it a long ways here. Okay, so now no doubt the bottom has gone wild, but let's go take a look at the bottom here. That's 640 now. I'm going to try to... So the only way to bring this back is to move that. Well, I'll use the capacitor. We'll do the wrong thing again. See how sensitive it is. A little bit. I've tightened it down quite a bit. But did it go the right way? It did.
Hey, great customer service. I'm telling you, I got the best in the business. There's no two ways about it. Let's talk about COVID.
So it's clamped down super tight. So I'm going to move this with the inductor now.
425 new cases. 2 people have passed with COVID and new cases 178. Completed tests nowhere near. started to reset.
Capacitor.
Yesterday, it was 40,000 plus.
Gonna back it off a little bit. Wow, that really tuned, didn't it? Okay, back with the inductor.
I have to say, in the age group that the majority of COVID cases are in right now, under 40. 50% of all cases are under 40 in the province. And we are, the goal for that.
In Canada here, we're very worried about a resurgence of COVID, just like just about everybody in the world. And our current statistics are starting to go up. We got things really low, and all summer they've been slowly rising. And now, of course, in the fall, for a number of reasons, just like everywhere, it's going up here. It's getting a little scary, because you know how this works. It's out of control before you know it's out of control. This is the problem here. Things still look okay when in fact it's out of control, and by the time the roosters come home, it's all too late. And everyone knows this now. It's quite anxious. We're trying to do the school thing, the whole shot. Okay, enough of that. Don't talk about that. We're trying to hide from that in here. Well, 640 seems to be 640. I'll go up and see what happened up here. And am I mistaken? Did it actually start receiving a little bit better? $1,500. Shouldn't we hear it? Oh, I turned up. That's an interesting thing too. I have to turn my radio up so high. Where'd it go? Where did it go? I haven't got a lot more juice to feed into it. To make a more direct connection here, I'm going to go through the antenna connector at the back because of the weak capacitor. It may help. That's a different arrangement now. Where'd it go? Okay, we got a big. Maybe I didn't put. Maybe I just moved the wrong lead. Did I? No. Sorry, lead. What happened here? Hey, this is not going well. Now the idea is, okay, now we're going to use the proper controls to try to drive this thing back to where it should be. Oh my God. Good luck on that. So, capacitor. Wow, here it come to life. I like this. So now we're reaching rock through territory here. Oh, just touching the screw upsets it. Just listening to how loud it's getting. Where is it? Got the antenna hooked up. That can't be helping. Okay. 15 with the screw wide open. Antenna back on. That would mean my neighbors were listening to that on their AM radio. My signal generator being broadcast. Can we get 640? Yeah, a Canadian TV comedy show swept the Emmys. A show that's shot not too far from here. Okay, now we're using the proper adjustment. I'm going to try to put this over to 640 here. I'm going to do the two RF, the antenna trimmer and the intermediate trimmer. Do it wrong, Jim.
It's worthy audio, but I really want to be able to set it up properly. We're going to talk about John Turner, who passed away in a way that I think most of us look at and think, well, if
That's really supposed to be done at the 1500 end, so let's do that. Oh, this radio sounds better, I think. Right, 1500. I don't hear 1500. I think that's it way up there. The low signal. Yeah, that's it. So I'm giving it quite a strong signal now, directly into the regular antenna input. So this is quite weak reception. The capacitor for adjusting this is open. So if I wanted to go this way, I would have to open it more. Let me close it. Yeah, I'm going to open it more. There's no more. I'm at the limit. Okay, now adjust the RF trimmers. The two trimmers. They may be not much difference down here anyway. There we go. Oh, a very distinct peak. AVC is kind of affecting the adjustment a bit. You know what it sounds like? Right in here. Now the other one. Tighten it right down. Ooh. So I'm going to turn it down. I'm going to take off the antenna connection. I'm going to feed the signal generator into the wire lead, bypass the weak capacitor, give it a stronger signal, cut it back. AVC interference is minimal. Can't even find it. Let's try to get a little bit. Okay, that's a fairly low signal. And the trimmers. Same spot I found earlier. Now this one. Just doing it by ear. This one wants to just close all the way. Okay, so that should be as sensitive as it gets. Come off the signal generator, back onto the antenna. Let's go see what we can hear. What can we hear? Now, there should be no signals up here. I'd be lucky if I can get one around here or in this area. So if something shows up, yeehaw! It's a station there. Yeehaw! Yeehaw! Not many radios picking stuff up here in my shop. If I brought in a modern, regular transistorized loop stick radio and turned it on here, and I have them, they pick up stuff up here. It's these old guys that have trouble. Or is it the me? Tons of interference in here too. Can you do it? Can you do it? .840 has a station. .740. That's 680. It's not bad. .640. Very close. 590. .590 there. So I'm going to adjust the oscillator control for this end of the band, which is the inductor, and move this to where it should be. Got much louder. Okay, 640.
He had agreed with Pierre Trudeau to make some patronage appointments for people that Pierre Trudeau wanted appointed to the Senate and so on. He went along with that.
RF adjustments just to see what happens.
Well, when he raised patronage during that leadership debate, Mulroney turned on him and said, "You had a choice, sir. You had a choice to turn your back on the old ways of the Liberal Party," and everybody generally believes that's when he lost the election, and Mulroney went on to have one of the biggest victories in Canadian political history.
Is it true that he once dated
I remember what they're talking about. Okay, I have beat the living heck out of this, and I think I got somewhere. Further, surprisingly enough, I think the plate bending thing is, you know, if you really want to get right to the limits of what these guys can do, you got to do it. So what happened to the 31 meter band during all that? Was it the 31? Is it the 31? Let me just pop the instructions up here on my own screen. Yep, step number 5. 31 this band, not 31, C band. What's happening? Okay, so I have an outdoor antenna connected. Signal generator's not. Is that correct? That's correct. Well, it's just there's no sound. It's a very strong station at 9.3. That's way out here.
In the future, we'll do it again. Truth is what is important, not main facade of it. Please, afraid to step new steps. That's precisely why Yah is commanding all of us to leave Babylon.
I'm reading the wrong
He's got
scale.
so many truths, yet
9.3.
knows that if we're trapped
This is
inside,
probably
we won't
9.33.
be in a position to respond. This is very true. Be able to think outside the box, too. Behind inherited doctrines. Set aside.
Very hard to tune this radio on this band.
For example, the phrase time of trouble.
So you can see that the band spread is spread so much it doesn't even cover this. Must be just off.
And yet, new light in the book of Daniel reveals that we have been
That's roughly
in the time of
9.3
the end
there.
ever since 7.
Let's keep going. Didn't the radio come to life up in here? Here it comes.
Me atendieron allí. Yo llevaba unas medicinas que era la que estaba tomando.
That's Radio Cuba. It's a European shortwave band rating here. It's 11 o'clock in the morning here. The volume is full. So that's pretty dead. You know, you should be hearing the atmospheric type noise. Nothing. Yet it's just full of life right here. Is that because that's the shortwave conditions today? I don't think so. I think this radio is hot right here and cool everywhere else. Well, it's hot around. That's this band. Let's go up there. Why not? Once in a while, I actually listen to shortwave radios. That sounds great.
Su billetera pagó 20 pesos y ahí fue donde yo lloré más todavía. Así mismo. Porque una mujer me regaló 20 pesos para comprarme medicina. Y yo estaba solo aquí en Estados Unidos, solo. So, esas son cosas que, oye, a uno le pega duro en el sistema nervioso.
There's a dot there. It says London.
Esa es la historia. Yo me alegro que y las mentiras.
Once, you did it again.
Decía, es muy importante una cosa para concluir acá. Gratis, señores.
Those are fairly strong stations too. Overall, the radio seems to be a little weak. Generally, and then extra weak. It's not that bad. Hey, wait a minute. This was the band I thought was kind of shot. This is the one I had targeted today to fix up. And the only adjustment there is for this is the oscillator adjustment. So let's check that. Okay, let's keep going. Keep going. No, we're up on this band now. Jim, get your head. No, let's not keep going. Yeah, let's not keep going. That's enough, because I'm going to saturate myself. I'm going to accidentally undo the goodness I've worked into it, what I think is goodness. If I keep going, tomorrow we'll just do all the shortwave bands again, and see what happens. So, well, okay, I'm not exactly sure what happened here. Maybe I went all the way around and got back to the same spot I was in. I don't think so, though. I think things are a little better off. I think bending those plates is the way to solve the problem of the trimmer that's wide open and can't find a peak. There's too much capacitance in the system. You got to reduce it somewhere. Plate bending helps you reduce it. Bring the overall capacitance down within the range of the trimmer. That's my theory. Okay, well, thanks a lot for watching. And another sunny, beautiful day here, but cool. Happy day for cats. They love it. And I'm going to go out and enjoy it too. See you on the next video.